And we are live, David. Thank you for joining me today. It is again time to learn SQL with Trino from the experts, me a little bit, and David a lot more. Thank you for joining me, David.
Glad to be here.
Cool. Awesome. Well, you're definitely the expert when it comes to some of the things we're going to be talking about today. We had Martin join us last time, and next time we'll talk with Martin and Dane as well. Martin, Dane, and David are the co-creators of Trino and CTOs at Starburst, and know Trino from the inside out and back and front. So they're truly the experts. Myself, Manfred, I'm a Trino maintainer and advocate at Starburst. I helped write Trino the definitive guide, so I know a little bit about Trino as well. So together we can hopefully teach you about some SQL stuff. Specifically, we started with getting started with Trino and SQL in October. Then we did some analytics with Martin last time. And today we're going to go a bit beyond what Trino was originally created for, and that is getting data in and out. So specifically a focus on in. Which means that we're going to write data. That is not something that Trino was originally very much created for, but it is by now very common use case and very, very feature rich, in fact. And you'll see it's going to be super interesting. And David knows a lot about that for sure. Next time, we're going to talk about functions and more functions, also known as SQL routines and other things, which will also be fun. For the class today, we're doing this introduction at the moment. Then we'll have a lot of material to learn about SQL with Trino, and we'll also include a QA session. So for those of you that are online right now, please do feel free to ask questions on the chat system. We'll try to sort of like capture them all, potentially ask anytime, and we'll try to answer them if it's in context, but less than Jesse in the background are helping us as well. So thank you for that, and we'll keep a bit of an QA session afterwards. We'll probably try to be roughly done in an hour. But if you have lots of questions, we'll be here. This is going to be a relatively fast-paced overview. The training material and everything is available online. The SQL statements and everything, as well as the slides, all of this is available. And there will also be a recording. So you don't have to try to follow by writing along or typing and stuff like that. Just like watch and later learn at your own pace with the recording and the material available. And of course, then you can also adapt those skills for your own use cases and create your own data tables and whatever, and experiment more. Today's demo will largely be done again on Starburst Galaxies. Thank you for Starburst for allowing us to run these demos and use the free accounts for Starburst Galaxy. Anyone else here in the audience also can do that. You can sign up for Starburst Galaxy. Starburst Galaxy is basically a hands-off, easy-to-use Trino in the cloud for you, which is great because you don't have to worry about all the lower-level details and just get going right with writing your SQL and doing your analytics. So let's go and learn some SQL with Trino. And that makes me jump over to this available presentations that we have online available. Today, we're doing data management with SQL. Last time we did these other three. So you can all see them online on GitHub. So we're going beyond analytics today. And on that other side of analytics, obviously, you need to manipulate data, right? Like, as you know, all the last time we had data, we had tables, we got the data out, we converted it a bit, but ultimately we never wrote or created data. And when we did that, we had the same structure that we also have to obviously deal with today. There's data sources, those data sources connected as catalogs. In those catalogs, one or more schemas. Inside are tables. Those tables have columns and rows. And the data access uses this catalog.schema.object kind of namespace and naming, and that still applies for our write operations that we're going to be doing today. As I mentioned so far, we learned about analytics. So those were globally available statements and read operations. If you look at those in the Trino documentation, you see there's a whole bunch of them. We'll be using some of those again today. And then read operations, we'll also be using some of them. The main one, obviously, for read operations is the select statement, which is very, very complex and can do a lot of things, but mostly it basically gets out data and massages it to represent what you want to show. All of this is supported by all data sources and Trino connectors. That's pretty much true, right, David? Can't remember there's a connector that doesn't support the global available and read operation. It's kind of a minimum requirement for getting a connector into Trino, isn't it?
Yeah, having a write-only connector would be pretty weird. I don't think we have any of those.
Yeah, so that's cool. And good to mention it. That is where we're going today, writing operations in Trino. And as you can see here, there's a wide range of write operations that are available. So as I mentioned before, there's catalogs and then schemas and tables, and all of those have management functionality. And we'll look at those today. So can you create a catalog? Can you create a schema, a table? And then the main aspect is data management. We'll also talk about view and materialized view management. And then next time, we'll talk about routine management. If you look at this in the Trino documentation, again, you'll see there's actually quite a bit of commands involved, right? So you see insert, update, delete, truncate, and merge. We'll cover all of those today. We'll talk about materialized views, catalogs, schemas, views, and routines come next time. So there's quite a bit of ground to cover. One thing that's interesting, and we should talk about this a bit more, is what's necessary to write. And that is when you use Trino and you connect to a data source with a catalog, the data source needs to even support write operations. So, I mean, for a relational database like Oracle, so that's obvious, but I'm sure there's systems that don't make so much sense to write data. Like, David, can you think of any that we have a connector for where it's a bit weird to write data?
I'm not sure we support it for Google Sheets.
Yeah, that's true, actually. Like Google Sheets, although for Google Sheets, it would make sense to also potentially like write into a spreadsheet. But I think one thing that's also weird to write data into would be something like Kafka, right? Like that's a stream, right? Like if you write in a stream from Trino, you just sort of flows by. That's maybe a bit odd.
Yeah, or connectors to external systems like SaaS APIs. Like I think Starburst has a Salesforce connector, and like that's read only to like pull your data out, but it wouldn't make sense to write data back in there.
Yeah, exactly. Like if it's like an application log or so from another application that you read or so, right? So like the data source basically needs to support and needs to make sense to do those write operations. Otherwise, what are you using Trino for, right? And then of course the second part of that is the Trino connector, which is that implementation that we have that does then connect to the data source, needs to support write operations. And we have plenty of connectors that don't support write operations. I think it's kind of like a historic and also a momentum question, isn't it? Maybe, David. Like historically, we just had more focus on analytics, right, with Trino. So it's kind of a requirement that a connector supports read. And then obviously adding write support is more work, isn't it? Like what's the level of effort you think is required from lifting a connector from read only to write on a like sort of...
Yeah, the connectors in Trino are contributed by the community. So if people only needed read support, then like that's what they're going to implement first. And if nobody ever needs write support, then it won't have it. Like I think Redis, for example, doesn't have write support just because no one who uses it has ever needed that.
Yeah, no, that makes sense, right? Like so that's also a kind of cool call out, right? Like if you are using a specific connector and you think it should really have write, we are an open source community, so we would love your help to work on those. And in many cases, it's actually worth looking at other connectors. Say you're like looking at a connector that is like using a JDBC driver and doesn't have write. Well, you can probably look at like the PostgreSQL connector as an example and see how that's written there and sort of like lift and shift and test, right? But obviously it's important to like do that work, right? So that'll be cool. Another thing that's important and also often overlooked is, David, right, is the data types need to be mapped in this connector, right? Like sometimes I get like these bugs that I see flying by where if a data type isn't mapped in a connector and but is available in the data source, then it's not potentially possible to write. Is there some hacks around, or is there some common examples you can think of? Like last time with Martin, we talked about the money type, for example, that some database systems implement.
It depends on the connector, but it's a good point that read and write support doesn't have to be symmetric, because there might be things where the connector has for example, maybe it represents internally something as a number, but in Trino, like maybe in a weird way that doesn't map onto Trino. So when you read it in Trino, you get back a string, but then when maybe the connector wouldn't support writes because there wouldn't be a good way to go back from a string to the connector's internal representation. I can't think of any off the top of my head, but that's definitely possible. Like read and write support at a connector level is different, and connectors can implement different levels of support.
Yeah, and we have the documentation also, so that's something worth looking for. Another aspect that's worth knowing is the credentials that you provide, or like whatever access details you provide in your catalog to configure access to the data source needs to support write access, right? So if you give a read-only access to a PostgreSQL database and use that in your Trino catalog, well, then Trino can't write because that it will just get access denied kind of access. So you need to make sure you have the right level of access on those credentials in your catalog. And that's very important, because on the one hand, you want to give the right access in terms of like being able to do those right operations, but on the other hand, you don't want to use like a full-on like administrator kind of account either, right? And maybe have even different catalogs and stuff like that. So that's worth thinking. And then Trino also has a separate security configuration. So let's look at some of these, how you can check those out. So the connector documentation that we have in Trino, all of them have a SQL support section. So like if you go to Trino documentation here and you look at your connector and you go, say, for example, I don't know, like let's go for like Postgres for example, you can go to the SQL support section and it'll tell us here it has globally available and read operations supported, and then in addition those, right? So schema and table, and those all link to the relevant details. But for example, you don't see like view support here or routine management, right? Because that connector doesn't support that. When you compare that to, say, the Iceberg connector and you go to SQL support section here, well, it has a different section with more support for more things, right? So it also has more details related to some of those things in each connector. So that's important to understand. You need to look that up. Depending on your use case, a data source might be suitable in a connector, or it might not. So need to check that out. The security configuration on the data source, well, I can't give you a generic way of doing that because every data source has different security configuration, all the way from like not having any and relying on external systems to secure it, like Elasticsearch, for example, does that, to like, very, very fine-grained all sorts of connection, like security access controls, or having other systems, right? Like in the Trino community, we often hear of Ranger. You'll also see like Starburst Galaxy has its own access control. So there's all sorts of systems that you can use to secure those data sources. And it's important that they are configured to allow write access. And then Trino also has there's the read-only system access control. Well, if you have that switched on, writes will just fail, right? So literally just like you can still write a SQL statement, like create something, but it will just like fail with an error message. Is that right, David?
Yeah, that's right. You'll get an access denied.
Cool. Yeah. So nice and easy, tells you nicely. And then also the file-based access control, also in Trino directly, also has to have that sort of access. And of course, when we later demo in Starburst Galaxy, if you look over here, I'm just going to be lazy and like use everything as account admin, so I have full access. But if you like train that and like you're setting up different access controls with your Starburst Galaxy access control setup here, you can set it up so that some users can do those options and others not, right? So that's the convenience. You can just click around in the UI and define the security policies. Obviously, security is still complex, but at least you don't have to like write files and that kind of stuff. So those are the things you need to check out. And now we can actually start getting stuff done. The first one is catalogs, right? That's the highest level. That's the configuration to access a data source. And typically, you do this by things like either writing a catalog properties file. So I can actually show you here. Let me see. So if I go make this a bit bigger, I have a Trino server running here locally that I configured. So if I go ls like etc catalogs, you see I have an Abyss, monitor, sample, and TPC-DS catalogs configured, and those are just simple property files with more or less configuration in them. These are the ones that are from Trino, the definitive guide. So if anyone wants to like play around with these, they are here available. So you could do those, or in Starburst Galaxy, you would just go in here and like go click around and configure everything in the UI. That's also super useful. But what we want to do today is we're going to show you something that's also really cool. It's a new feature that's kind of experimental, but actually works really, really well already. And that is dynamic catalogs. So if you configure in your config.properties in Trino to set catalog.management to dynamic, by default, it will basically manage the files, those catalog properties files. And you can now create catalogs. So I can show you this. This is pretty sweet, actually. So if I go show catalogs here in dbeaver, this is just dbeaver, me connected to that local server that I just showed you there, the 433. And you see here, there's the same stuff. Abyss, monitor, sample, system, and TPC-DS. System is always there. That's the system information. And then the others are the catalogs that are there. Now, with the new support, and because I switched this dynamic on, I can run this create catalog brain, and it successfully ran here. I can go create another catalog TPCH, also ran. And now if I go show catalog, you see there is the TPCS and there is the brain catalog now. When I ran these commands here, there's two things you notice here. There's brain, that's the name of the catalog. So that's what I'm going to access that later. And then using memory, that's the name of the connector that I'm using. So that's the same as when you are going connector.name in the properties file. That's the same kind of name. And it's documented for each connector in the Trino documentation, what those names are. Typically, they're always like for Hive, it's Hive. For Iceberg, it's Iceberg. For PostgreSQL, it's PostgreSQL. So there's no real surprises there. And so I got my catalog and it's ready to go, which is pretty sweet. I can also drop those catalogs again. So you can create them, drop them. So that's really amazing for managing your cluster. It's experimental because there's some implementation details that we need to sort out in terms of like these security aspects that you potentially have to add to the catalog. Like here, they potentially are available in the log. So we need to do some masking and other stuff. And there's also some memory things that we need to sort out. But I think it's getting closer and closer to become a real feature. And we would love for you all to play with it. This is a more complex example. It says it uses the PostgreSQL connector. And then this is the with syntax that Trino supports in many cases when it sort of like needs to go outside the spec. And in this case, we're setting 4 properties. Note that the quotes here need to use double quotes because dashes are invalid in SQL. So but those are the property names that need to go in the property file. And then here we are quoting the various connection strings. So this is the JDBC connection URL. Then we're setting this using the secret. So, and you can do that and create your catalog, which is really, really cool for bootstrapping a cluster. Creating that catalog was really just a preparation though, right? Like it's important to do that, but it's not really that common, right? Like once you have your data sources configured, David, how often do you think people do that typically? Like this, not that often.
You do this once while you're setting it up. So like dynamic catalogs are really a feature that are mostly useful in the beginning when you're experimenting and like you want to iterate quickly and mess around. But usually once you have your cluster like configured to your data sources, it doesn't change very often.
Yeah, exactly. So we'll see how that
taken us so long to add dynamic catalogs. Is that like people, when they're getting set up, like they wish they had this feature, but then after it's running, nobody cares. So it's actually, for a long time, it wasn't a high priority to add.
Yeah, and it's actually very complex because what it needs to do is, as you know, Trino is a cluster that we talked in prior classes. So it's not good enough to just create a catalog on one node. The same configuration needs to be there on all the workers. And then there's timing issues, like if they're not on all of them and those kind of things. So it's not that easy to implement. But Dane successfully fought and won that battle. So pretty impressive. It's a very cool feature. And I think there's some mechanisms in there to like distribute this kind of configuration across the cluster that might be useful for other configurations over time as well. So definitely very cool to play around with. So let us know how it goes if you're playing with it. But of course, if you're using Star Wars Galaxy, you don't need to worry. You just like, you just create your catalog and it takes care of it for you.
Yeah, dynamic catalogs were a big feature to add to Trino. It's like Trino's always been designed around static catalogs that you restart the cluster. So doing everything dynamically was a lot of work.
Yeah, it's very cool though. I love seeing it. It's one of those like features that look so simple, but it's very convenient, and for playing around in demos, it's very useful. But what we want to do now, before we talk about creating other things in that, we need to talk about a bit about the difference of the data sources, because ultimately the data sources are very different that Trino supports, and those differences do bubble up to you as a user, specifically when you're writing. Reading, they also bubble up because obviously like something like Elasticsearch has more JSON documents in it than like say Postgres or so. But when you're writing, these kind of differences bubble to you and become more evident, even more so. So let's talk a bit about that. Object storage connectors or data sources here are in our system Hive, Iceberg, Delta Lake, and Hudi. They typically deal with files in a folder structure, probably on some cloud storage or so. Ideally, they are columnar files like org and parquet, so that's much more high performance. Hive also supports others like JSON or CSV, but ideally you don't want to deal with that because there's more performance impact there. They use these different table formats, table format like Iceberg or Delta Lake that contains metadata. That metadata storage is required. So besides the files, like the raw files, there's also some metadata storage required, and that's something that's necessary. And object storage on its own with a metastore doesn't do anything. It needs a query engine like Trino, right? Like there's other query engines around, but on its own, it doesn't do anything. So that's why Trino is sort of the first kind of like, or can be the first and only access to your lakehouse or data lake as a SQL engine accessing it. That's a bit different from others, and we'll see that in a second. The object metadata, the object storage metadata, there's two aspects to that. So on the one hand, there's the files have some metadata in it or can have some metadata in it, and then you need a metastore. And like the most common one is probably still the Hive metastore service, right, David? And that's software out of the Hive/Hadoop ecosystem. It uses the Thrift protocol. Is that right?
Yeah, you connect it's with the Thrift protocol.
Yeah, so that's a custom protocol out of that ecosystem, isn't it?
Thrift actually is an RPC protocol that came from Facebook. It's very similar to Google's gRPC or protocol buffers.
Oh, okay, cool. All right, so that's the Hive metastore service. You need that, or alternatively, if you're like an Amazon user or so, you have a Glue catalog, which is a sort of compatible replacement as a metastore. And then in the Iceberg ecosystem, there's also REST, JDBC, and Nessie catalogs. So you need that additional metastore. So when you're configuring a catalog, you need to, on the one hand, configure the access to the object storage, which is typically a URL to like S3 or MinIO or Google Cloud Storage. And then you need that meta store, right? So it's not enough to say, oh, I have these files. There's a bunch of S3, like a bunch of CSV files on S3. What am I, like now I want to query that with Trino. That's not good enough. Like you need that meta store. And that's something that beginners often fall into. And Trino then query them, right?
Yeah, the requirements for the meta store are actually different depending on the file format. So for Hive, like Hive is very dependent on the meta store. Like the Hive meta store has lots of information, like where are the partitions, where are the statistics, all the metadata, like all the metadata for Hive is stored in the meta store. Whereas like Iceberg and Delta Lake, the metadata is actually stored on the file system, and the meta store just basically has a pointer to some storage location. And then all the metadata is actually read off the file system. And so for Hive, the performance and like scalability of the meta store has a big impact on your queries. Whereas on Iceberg, like the meta store is just kind of like you read one piece of information and then it gets out of your way.
Yeah, so that's important also because the meta store, when you talk about the Hive meta store service, that's actually like a service application and then an underlying, like, I think relational database, right? Like Postgres or something. And it has like lots of tables and stuff. So if those are not performing enough for your object storage, that's not good.
Yeah, and big installations, like you can need a beefy server for your meta store and your the database that it's running against.
Yeah. Or you migrate to Iceberg or Delta Lake, then you don't need that. So that's very different because a traditional relational database and other data sources, they typically manage the query and the storage. So they include a query engine. So something like PostgreSQL, it's a full database. So you can already write SQL and then it accesses it, right? So they support some sort of SQL natively. There's no meta store necessary. Well, there is, but it's part of the database itself, basically, often like visible in the information schema and stuff like that. And they support some SQL natively, and the access from Trino is via JDBC driver or API access. The difference from you as a Trino user is that you can run SQL queries in Trino, and it's kind of like an additional query engine and user interface. But that's a good thing because it allows you to access multiple data sources. So you can query multiple Postgres databases at the same time, or you can combine and use that same SQL to also query your object storage or your Elasticsearch and others. So Trino is kind of additional. So sometimes you can fall back. So if the underlying, like say your connector doesn't support a specific operation, but the underlying data source supports some SQL operation, then you can do that there. That's also something we'll see later when we talk about the views and materialized views, how there's some differences as a result of that. So from all those differences of data sources, ideally that's irrelevant. That would be ideal, but practically that's not the case. So those differences do show up in Trino. The connectors have different SQL support. The type, availability, and mapping is potentially different. And then also advanced features and convenience features are also different for each connector. And we'll encounter some of those later on when we talk about procedures and stuff like that. So now that we have those kind of differences out of the way, and we know that different things will work differently, we can play around with the next thing. And that's important to understand because in Trino, underneath a data source / a catalog, you have a schema. And a schema is a different thing depending on the data source, right? Like what's a schema on object storage connector, typically, David?
Usually a schema just points at a file system location. That's like the default place where tables are going to be written. But
yeah,
like
so it's just a directory, really, right?
Yeah, it's really just a namespace for all the tables.
Yeah. So, and that's very different, right? Like in PostgreSQL, it's an actual database. And I think in MySQL, it's an actual difference. And like, but the database server, and you can have multiple schemas there, versus MySQL, you can only have one and stuff. So it's different. And like, obviously, in Elasticsearch, the term for it is different again. It's like an index or whatever, right? So there's basically a schema is like a namespace within a catalog. So keep that in mind. And you can create those with Trino. So you can go create schema. This is kind of the like syntax for it. And you see that there is authorization that you can define in Trino, and then also a bunch of properties. So what can that look like? So I can go, for example, here and create this schema brain.demo, and you see the namespace comes into play. So oops, sorry, wrong. So if I now go show schemas from brain, you see there's the default schema, and I created this demo schema. You also see there's an information schema. All catalogs in Trino have an information schema which exposes the metadata about that, and we'll tinker around in that a little bit later.
Yeah, information schema comes from the SQL standard, so pretty much I'd say most relational databases support information schema.
And Trino also sort of exposes one even for ones where it's not, right? Like if there's like an Iceberg catalog or so, Trino sort of like bakes one up and pretends that the metastore is an information schema, right? Essentially, right?
Yeah, information schema comes from Trino itself, and it uses the connector metadata APIs to return that. So information schema will look the same across all Trino connectors.
And that's very cool too. Like, if you're needing sort of like some information about metadata, you can poke around in there, and we'll do a little bit like that. Here's another example I'm not going to run. You can create a schema in some data lake and call it like lake.marketing. And then here you could, for example, also specify the location. That depends on the connector that you're using. But here, for example, I would specify some sort of directory structure, right? And you could also omit that, and then it would just create a directory of that name in the schema. That's the default for this catalog, but you can also specify it, right? So more of those kind of properties are available potentially, and they're called schema properties. Now, the next thing, and that's where it gets really interesting, is a table, columns with data types. There are in those table, obviously, rows of values for each of those columns, and they're located in a schema. So you can create as many as you want. The type mapping for the connector is important. So let's create one here, very easy one. Create table person, first name, last name, and date of birth. And you see the Trino data types are popping up here already. And then we can insert ourselves into this table, David. So we can go run this insert into values. So we're inserting those. And then you see here, I use the explicit date. And I made us a bit younger than we are, okay? So you see, very simple. I can go, and you see there's the table. I can go show the schemas from brain. I can also show the create table statement. So after I ran this table, you see here, this is the create table statement to create that table. That often also can reveal data types and stuff like that, or metadata about the table creation. You can also use this describe statement, which returns a nicer result set for it.
Show create table is really useful.
Pardon?
It's like show create table is really useful. Like I use that all the time when debugging data.
Yeah, because it also shows the with statements and that kind of stuff, isn't it?
Yeah, so you can see all the physical properties. It's especially true for like Hive and Iceberg tables where you've got like partitioning or sorting. Like you can see all those properties in show create table.
Yeah, cool. Yeah, so, and you see here, I'm going to also show you this hack. So you can go, this is an example for the system. You can go system.metadata.catalogs, and it shows you a little bit of metadata about the catalogs. This is the system catalog that's built into Trino, and it shows all sorts of metadata and other things. You can find like the number of nodes in the cluster, but also you can find information about your catalogs. In this case, this is one way to find out what connector is used in a catalog, which is not that easy otherwise, because say you have access to a cluster via SQL, but not on the file system, it's not that easy actually to find out. This is the way to find out what connector it is. And that's important because sometimes you need to know what information, like what procedures you can run. If you don't know what connector, you don't know what documentation to look up, so you don't know which like features are even available to you. So this is a way to find that out, and that's kind of handy. And there's also another example here. This one, we're looking at the information schema.
Let's say here you can see that like brain maps to the memory connector, whereas like most of the catalog names are the same as the connector name, but in the case of brain, it's different.
Yeah. That's for me trying to make sure that people understand, because what I can also do, I can do another thing. I can do like, I can create a catalog like Foggy Brain. And then I have 2 memory connectors. So that's very important to understand, right? Like a connector is just a means to connect to a data source. You can have as many catalogs using that connector as you want, which is very useful because you can, for example, connect to multiple PostgreSQL databases, or even connect to the same PostgreSQL database with different credentials, one with write access, one not. That's like a hack and workaround, but there's things like that you can do, right? So the connector and catalog numbers are not tied to each other. And then here's one last hacky statement. In this case, we're looking at the information schema. And you see here, I'm looking for the table schema demo and the table name person. And that kind of brings me back to a similar statement of what the describe statement returns, right? So the information schema also contains that information. So you can always dive in and find a lot more information about the table you created that way. So a very simple example. The full create table syntax is more complex, and you see there's some really cool features in there. You can do things like setting not null. So a table column can be set to not allow null values. You can, and again, this is important because the support for that then depends on the underlying data source, right? Like if that is enforced or not by the data source. You can set comments for each column, which then show up in those describe statements and so on. That's useful if you want to help people understand what your table is even about. And then you can also create a table with a like statement so that a table is like a copy of another statement plus some columns or minus some columns and stuff like that. And then obviously the with property name statement is also important because we can do stuff for setting table properties. We'll talk about that later though. So we checked out some of those things, how we can inspect catalogs, schemas, tables, describe them, and then also look at the data, at the metadata. It's good to see that this is useful. So the metadata varies a lot per connector, as I mentioned. You see that there is table, schema, and column properties and comments, and then the system catalog has a lot of that information available. You can literally browse around in your tool here, whatever client you use, and like literally look at all the tables and columns, or you can write statements to go. Properties set in the with clause, they are very important because they set things like the location we saw before, but also other behavior. David hinted at that, such as bucketing. We'll talk about that more here. So Hive, for example, so these different metadata aspects are different depending on the connector. So Hive, for example, the Hive catalogs that use the Hive connector have a properties table associated to each specific table. So if you have some random table in your Hive object storage, you can look at $properties, and that exposes all the properties available and set on that table. Note that if you want to do that, it's important to use these apostrophes because the dollar symbol is invalid otherwise, so you won't see those. Very important, like very useful. There's also a partitions one, again, with the dollar symbol. Partitions is a means to optimize the storage on the object storage itself, like how the directories inside it are organized, and that allows you to get higher performance read out of it. And with this statement, you can see which partition individual like setups are. And then for each individual record in a table, you can also look at some metadata. $path, $file size, and $partition are additional columns. So each individual record, you can actually look in what file, like what org file the data for that is coming from, what the file size of that is. And that then allows you to also figure out, you maybe have performance problems because all those file sizes are very small and stuff like that, without actually having to look in the object storage. So Hive metadata is very, very powerful and useful. That's obviously an advanced topic to worry about. And that goes very much into that like aspect of having to understand what's going on under the hood as well. Can you tell us maybe a war story or some things that you had with these Hive metadata tables and information, David? I'm sure you've gotten like a lot of experience with those.
Yeah, tough to think of something off the top of my head, but I've definitely debugged lots of performance problems using these types of techniques where you end up with like sometimes the file, like you have only a few files that are really big and they don't split well, so you don't get very much scalability, or maybe you have a table that has like 1 million tiny files and then you've got like way too much overhead. So also like partitions, I worked on systems in the past where like tables would have literally millions of partitions, and like that caused lots of problems for us. That we had to make Trino like very scalable and make sure not to do things like load all the partition metadata for all the partitions at once, because the coordinator would run on memory and crash. So
yeah, that's not very good, right? Like once the coordinate is gone, you're gone.
Yeah, Trino has to adapt to like basically whatever people throw at it, and like we've seen all sorts of crazy stuff.
Cool. And like, so these properties have proven very useful, because if you look at the Iceberg connector, there's the same thing. Here, there's like even more available. Now let's look at Hive some more. Here's an example for the data organization, right? Like here, for example, there's a create table statement. In this width statement, we're looking at some of those what's called table properties. And here in this example, there's a column called date and a column called country. And the data is very commonly written along, you know, like per day or something, and then per country. So if you partition it by date, by this DS column and the country column, you basically get subdirectories within it. So when Trino runs a query, how does that then work, David? What can it do? Like, it can just like analyze the where statement and look at only some things or something?
Yeah, so in Hive, partitions actually turn into directories on disk. So effectively, think of like each partition is a separate directory. And so if you have a where clause that filters down to only certain partitions, Trino only has to look at the files in the directories that match the partitions you're querying. And so like that's important when you have like huge tables with lots of partitions. You only want to be scanning the data that you actually need to answer that query.
All right, that's cool. So then it's kind of important on what you set those partitions by. You need to understand what queries you're going to run to some degree, right? Or like keep an eye on it anyway. Well,
you also have to be careful, because you don't want to have, if you have too many partitions and the partitions are very small, then that makes then you end up having like lots of tiny files, and that creates more overhead. So if you don't have partitioning, or the partitions are too big, you can end up scanning more data than you need. But if they're too small, then you'll have too much overhead and too many files. So it's a balance, and you have to be careful. Like in this example, actually, with like partitioning on country, you can have imbalances where like, you know, some countries maybe like US and China are like huge just based on like user size. Like let's say you're storing like request logs for your service. You know, the bigger countries are going to have much bigger, like more data, because there's more users there. And then you're going to have lots of smaller countries that have less data. And so you can end up with skew that like causes imbalance. So you have to be careful what you're partitioning on. And it really depends on, it depends a lot on the use case and like how you're writing the data and then how you're going to be reading it later. So
it's definitely an advanced topic then, in the sense, and like you maybe start off with not doing anything and seeing how it goes. And like,
I don't know if we're going to talk about Iceberg later. Like Iceberg actually, they've improved on Hive partitioning quite a bit, where like Iceberg, you can actually start off with no partitioning and then go and like change the partitioning later. Whereas in Hive, that's not really possible. Like pretty much in Hive, you have to the partitioning is fixed once you and if you want to change it, you have to rewrite the entire table. Whereas in Iceberg, you can change the partitioning as you go along for new data.
Yeah, obviously, like just rewriting the table is not always an option, right? Like if this a table that has tons and tons of data in it and is big in storage, it actually could take days to create a new copy, right? That might be impossible and also expensive. So yeah, I was going to mention that, but that's awesome. You hinted at that already. So
but we do a whole talk on physical data layout. This is a very
it's a very complex topic. And so, but it's definitely one where it's important to understand over time, but you can get away with not understanding too much in the beginning. So that's where we are at, and that's cool. If you look at the documentation, you'll also see that there's lots more to it, right? Like if you look at here, the schema and table management, where am I now? I was gonna, this link me. Yeah, here we are, table properties. So you see here table properties, there's a whole bunch to set, right? Like we talked about partitioning. There's also another concept called bucketing. You can set up like various, for if you end up working with CSV files, unfortunately, then you can deal with that in different ways. You set up the different formats. So there's a whole bunch of different properties that potentially are there for you to use. And also you see here, there's the metadata tables documented and the columns and stuff like that. So everything is available in the documentation there. Iceberg, as you mentioned, is very similar, but much more feature rich. Specifically, the possibility to change over time is there. Also, if you look at the documentation for Iceberg, you also see that table properties, there's a whole bunch of table properties, not as many because but there's much more metadata. So you see here there's properties, there's also history, snapshots, manifests, partitions, files, refs. So there's more metadata tables, and there's also more metadata columns. So more transparency, which is really useful for you to understand what's going on under the hood in more advanced use cases. But this is much more advanced than we wanted to go in level detail today because we don't have that much time. What we want to do is we want to add some data. So I'm going to do the rest of my demo now in Galaxy. And we are going to be going and doing that. Where am I? SQL Training 3. Here we go. So I'm going to create a schema. I'm going to use this AWS Pokemon schema from Monica here. So again, I can just run this statement. And that's going to create a schema. And you see here, my schema will show up. I can also run the show schema statement from AWS. I'm going to now use this statement here. So you see here, I'm now in the AWS Pokemon demo schema. And what we're going to do now is we're going to create the table person. Now this table is a bit cooler than what we had before. I'm also adding a column called UUID, and I'm adding a column called create timestamp, which is just a timestamp. Now I can again run my describe statement, and I can, for example, insert myself and David into this table again. And you see all it says is it inserted 2 records. And then if I go select star from this person table, there's the 2 of us. And what you notice here, what's cool is I use the UUID function. So when I create and insert my data, I don't just have to have raw data. I can also call functions and do all sorts of things to insert the data. So in this case, UUID is a function that, guess what? It creates a UUID, which is a unique universal identifier. And you see basically a large random string that's never going to be the same anywhere else. And then also I insert a date, and I set that timestamp to now, which is another function that just sets a date. And then this already allows me to do a little bit of hackery. So for example, I can do a little bit of analytics here. Super simple. I'm just going to compose our names and calculate our age by just using the date diff function, right? So very simple. Create a table, insert some data, and do some analytics. That can be done fairly quickly. And you see the create table statement here, inserting table, and we use those functions here, and that can be much more complex, obviously, what you insert there. And then we did a bit of analytics. Now, inserting that way works one record at a time. That is kind of like sometimes a bit slow. And in many cases, you also have the data already elsewhere. And that's a common use case in Trino. And for that, you can do something called insert into with the select statement. So you can literally go insert into and then select blah, 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 blah from some other table. Or you can even do that and transform the data on the fly. You can take that one step further and use what's called the CTAS statement, which is create table as select. And here's two examples. Very, very simple. In this case, I'm copying the TPCH tiny region table from the TPCH catalog into my current catalog. So if I do that here, you see, oops, so, not here. Over here, I wanted to do it here. So I can go create table region. And you see it copies those rows over basically. And if I go and look at this schema here, you see the demo schema now has my person table, and it also has my region table. I can do the same with another table where I can do the select statement, have some more analytics on it. So for example, here I'm just doing the US suppliers only by setting the nation key. And then I have a table of just the US suppliers, and I can then do some analytics around that. So you can create a table with analytics on the fly, right? Like you can even do like a count group by, for example, here. So the suppliers per nation, and then do some analytics where you use that table, right? So I used the supplier per nation, the supplier count that was pre-calculated and was into that other table, and then I show the nation name. So I can do that over here. Supplier per nation. And if this query only calculates the values, right? So but it just has the nation key, so that's not that nice. But it's nice enough for me to run this other query that pulls in the name. Oh, I did not create the table yet. Create table nation. Sorry, I have to also create the table because everything is like, I could also use the other schema, but I'm also having it all in here. So now I can run this query, and now I can see the nice country names and the counts of suppliers per country. So this is how I can do some simple analytics, but that's often not enough. The data can also be wrong. And so when the data is wrong, you can use further data management statements from Trino. And so we have update to change one or more rows. We have delete for one or more rows, which obviously removes that. Alter can change the structure of a table. There's alter for various things. Truncate can remove all the records from a table, and drop the table deletes the table. All of these statements, again, the support depends on the connector. So here, for example, I can do a little project here. So say, for example, I go back to this table person and insert myself and David accidentally again. And then I run this query, then I'm like, oh, now I have 2. That's wrong. So if I wanted to fix this table up, I could go, well, this record here, this Manfred is going to be transferred into Martin. So I just change this UUID. And now I see I update person set, and I set the various properties to a new value. So I can set, oops, enter. Sorry, I just pressed the wrong button. And so Martin was updated. If I want to update Dane as well, I can go select from person. And now let's change this one. And put this here. Now I ran 2 statements. Now let's just update the timestamp as well to now. So in this case, I'm updating the person table and I'm setting all the timestamps to now. So now I can look at that. So now I have all 4 of us here, Martin, Dane, David, and myself. But actually, let's go and delete myself. Now, if I go and look at this, we only have the co-creators in here, Martin, Dane, and David. And I can, for example, run and add another column to this table. So I wanted to add the column timestamp. Here's an example where the underlying system bubbles up. So you see here, Iceberg, timestamp 6 needs to be set, not just timestamp. So I added that. So if I go and then, so now this table, if I go run it again, the table now, oops, what's happening? Enter. So now this column has the update TS column. And then I can also add or change the table, like add the column role, for example. Now, if I describe this table, you see now it has the TS and it has the role as well. Now, what I can also do, and I show you a cool command now, that's the next one, that is the merge command. Because so what we did now is we inserted records, we updated records, and we can do some more now. So in this following statement, I'm gonna create, I have a second table now. So if I look here, now I have a copy of the table, person and person 2. I'm gonna insert myself as maintainer into this new table. So imagine this is like the transactional system where more data goes in all the time. And the second, or the person table is sort of like the data where like it's all queried from. The merge statement here is really powerful, but what it allows you to do is it allows you to basically compare records in 2 tables. And when they match on a certain criteria, do something, and when they don't match, do something else. So for example, here, if I go and look at the person table now, you see there's Martin, Dane, and David in here. In the person 2 table, there's myself as well. Now I can do an update statement where if you look at this, the role for me is maintainer, but Martin, Dane, and David have none, and the timestamp they have is also empty. So what I can do is I can run this merge statement, which is very powerful because it allows you to do all these operations in one statement. When they match, I set the role to co-creator. So theoretically, these 3 should go co-creator. They should also get the timestamp. And then when not matched, the data gets copied into. So person currently does not have my record in it. If I run this statement, the person table will get my record into it, and the updates to the person table will all be performed. So all of this stuff will be done in one go. And you see here there's co-creator, and the timestamp did not happen. I don't know why that didn't happen now. But anyway, so the merge statement allows you to basically do bulk inserts and updates all in one go, and that's pretty cool. Where's the merge statement supported, David?
all the data lake connectors. So like Hive, Iceberg, and Delta Lake support it. Hive only supports it for ACID tables. But,
okay.
Yeah, pretty much any connector that supports update and delete also supports merge. We actually changed the engine so that basically like they all use the merge machinery under the hood.
And it's always for two tables that are very similar in terms of structure, right? Like, or can you expand it to be more sort of like Swiss Army knife-ish? Because if you look at the statement here, you have to have some sort of condition for it, right? Like,
yeah, you typically use it when you have like a change log or like a CDC log that you're trying to update an existing table, like based on some changes from like some change feed. But there are other use cases for merge as well.
Cool. So a few things we still need to talk about. And yes, I realize we're a bit on over time, but that's fine. We're just going to keep going for a little bit. What we didn't talk about is if the data already exists. And that is something that leads us to what's called procedures. And they are important because, especially with object storage connectors, what often happens is some other system already added metadata in the Hive meta store, and like the table and the files are already there, but Trino doesn't know about it. So in Iceberg and Delta Lake, we have the register and also unregistered table procedures. And so you can basically do something like this call. That's a SQL command. And you call this is the catalog name. It's the system schema that's automatically there provided by the connector, and the register table procedure. And then you register the schema table name and location. And then from then on, the metadata is populated properly, and you can like use that table in Trino and whatever the other system is as well, if there is another one. Or if it's a migration, you just do that once, and then you let Trino run with it. In Hive, you use the create table statement, and you use what's called external location as one of those with properties, right?
Yeah.
And so there's also unregistered table. There's other procedures as well. So Iceberg has one called migrate. I already mentioned that register and unregistered table are in Iceberg and Delta Lake. Hive, Delta Lake, and some of the JDBC connectors also have a flush metadata cache procedure. There's the vacuum procedure in Delta Lake. So different connectors basically implement different sort of data maintenance and procedures, and they always use the call statement. There's another way that also is sometimes there, and that's a table procedure, I think is the right name for this.
Yeah.
Where you use the alter table command on a specific table. Because like, think about it this way, these procedures, they are for the overall kind of catalog, versus this kind of procedure is on a specific table. You see here, it's alter table, whatever table name, and then it's executing the optimized procedure for a certain, like you can do with where statement or without. But basically, in this case, for example, the optimize one I wanted to mention, because we talked about the little files and they can be slow. Optimize can allow you to make them, like compact them together into like lesser, bigger files, and like basically optimize it for performance. And Hive, Iceberg, and Delta Lake, for example, have that procedure, right? That's like very common use case to work with this procedure, right, David?
Yeah.
And it's important to understand that you do want to use this where statement or some where statement, because otherwise it does it for the whole table, and that potentially means you're doing it again for something that's already optimized, and then that might take longer, right?
Yeah, and it's often like if you've got a massive table, you want to break it up into like a series of steps. So like in case the query fails in the middle, or in case like you don't want to like overload your meta store, it's good to like do things in chunks.
Cool. All right, and that rounds out our session. I do have material about views as well. What do you think, David? We have a bunch of things to talk about views. Should we wish through that without the demos?
It's up to you. It sounds like this could be a whole talk by itself.
Yeah, maybe we'll do another talk about that another day. Let's see what our chat is like. I can't see the public chat. So let's see what there's any questions. Maybe what we'll do is we'll do a follow-up question about views. The slides will be available. And we'll go and look at some of the questions and answers that we can hopefully provide.
I've been monitoring the chat there. I don't think there are actually any questions to answer.
Okay. Cool. Well, then.
Oh, actually, there was one question from Jan about, he asked if Glue is limited compared to the Hive meta store, and are all Iceberg catalogs feature complete? So the Glue and Hive meta store are similar. I'm actually not sure if Glue has any like feature limitations to Hive. I can't think of any off the top of my head. There's definitely different performance characteristics.
Mm-hmm.
As far as I know, all of the Iceberg catalogs support all of the features. There might be a few, like at least all like the core features of like reading and writing. All the Iceberg catalogs are going to support that. I don't know. There might be some other more esoteric features that aren't supported by all the catalogs, but.
Yeah, I think there was a difference between like supporting materialized views or not and stuff like that. So there's definitely differences with that. We just had a discussion about that also. And I know there's PRs coming in for the Nessie catalogs. So there's constant developments there. Like the Iceberg ecosystem is very dynamic. There's lots going on.
Yeah, the core features should all be there in all the catalogs.
Cool, and that's awesome. Yeah, so if there's no more questions, I wanna all like let you not forget about Trino Summit is coming up. So obviously today's episode is recorded. We're going to publish this again on the Trino blog, so you can look at the slide deck and recording there in a couple of days. Trino Summit, please do register. It is going to be super amazing. We have just sort of finalized our speakers, and there's some really, really interesting talks coming up. I'm already very excited for that. It's only a month away, so I'm already shaking in my boots. David, you're gonna have to help us with the keynote again. Get that ready. But we also have the Starburst forum for questions. Obviously, the Trino Slack community is also available. The Trino presentation and get started repositories have the slide deck. More training material is available on Starburst Academy as well. And we're doing a Trino SQL training again in 2 weeks' time. And I promise I will probably have too much material again. This is coming to be a bit of a theme for these training classes. And so we will see you in 2 weeks' time or at Trino Summit. So thank you for jumping in. Thank you for joining me today, David. Always good to have your insights and get to understand some of the more technical details. I hope everyone had a good time.
Yeah,
any last word, David?
There were a couple of comments on the chat that Jan says Glue can't handle some schema evolution operations that the Hive meta store supports. So like alter table set data type, I guess the Glue might not support some of those changes. And George mentioned that transactional tables aren't supported with Glue, which is true. Hive acid tables require a Hive metastore. None of the other metastore implementations support that.
Yeah.
I want to say thanks Manfred, for doing this training. I know it's like doing these slides is a huge amount of work, and so I'm glad I didn't have to do it this time. So thank you.
No problem. I'll probably rope you in for the views because it's a very interesting topic where it's not like on the surface it looks simple, but it's not actually that simple. But once you understand, it all makes total sense. So I promise we'll deliver that some other day. All right. Thank you, everyone.
Thank you.